Hello, everybody. Time for our notes on the theory of continental drift. And our SWAVOT today is, students will be able to describe the historical developments that support the plate tectonic theory and summarize the contributions of scientist Alfred Wegener. So let's get started. Alfred Wegener was a German scientist, so you kind of pronounce the W with a V type sound. He studied meteorology initially, and he ended up proposing this theory that the continents drifted in 1915. And despite having evidence, which we're going to look at in just a minute, several pieces of evidence, most scientists rejected his theory at the time that he came out with it. They thought he was a crazy person. And one of the reasons that they did that is that he could not explain how the continents actually moved. Even though he had evidence that they did, he didn't know how they moved. It wasn't until the 1960s that the theory became accepted, and he died in the 1930. So this was about 30 years after his death. So he believed that all the continents were once part of a supercontinent named Pangaea, which means all earth from the Greek words. It started breaking up about 175 million years ago, and there were probably supercontinents before Pangaea, so this has probably happened before. And what we need to really know now is that continents still move today. They aren't in a fixed position. They don't move very quickly. They don't move very much, maybe a couple of centimeters a year, but they still move now. So when Pangaea began to break up, they broke up into two larger land masses called Laurasia and Gondwana. So Laurasia ended up becoming North America, basically the northern hemisphere, so Europe, Asia, Russia, and Gondwana ended up becoming mostly the southern hemisphere, South America, Africa, India, Antarctica, and Australia. So India does move up to the northern hemisphere later, but these are the two main parts of Pangaea that they start to break up. So let's talk about evidence that Wegener had. One of the first pieces of evidence that he saw was that there were fossils of the same animal in different continents that were separated by huge bodies of water that really couldn't explain how the animals would have gotten there. They didn't, and they also may not have fit, like this fossil of this fern was found in Antarctica and Australia and other places, and that have totally different climates. So it doesn't really explain. So he found these fossils of the same animal in different places. So that's the first piece of evidence of continental drift, was fossil evidence. The second piece, and this is probably actually what got him started on this whole theory, is that he noticed that the continents fit together like puzzle pieces, in particular South America and Africa. So when you look at a map, it just looks like South America and Africa fit together. And so that's what started him on this curious journey that the continents moved. Another piece of evidence that Wegener talked about and discovered was that in years of past, there were these huge glaciers or large sheets of ice that traveled from the South Pole and moved across continents. Well, when you have huge glaciers like that, they create scratches on the rock called striations, which you can see in this photograph here, and they show the direction that the ice moved. And so when you found these striations, this glacial evidence in different continents, it showed the direction of the plate. And after all those continents moved, you could tell kind of where the origin of the glaciers were. And so if you look at this picture down here on the right, it kind of shows where the glaciers were and how they moved. And then when these continents split up, you have this glacial evidence in other continents. So that was another piece of evidence. The final piece of evidence was that he found, and other scientists found, similar types and ages of rock on different continents, mountain chains that matched up, coal fields, in like North America matched up with European, where they would have maybe perhaps touched. Maybe rivers kind of matched up from one continent to another, that they might have been a giant river in another when the continents were touching. So these landforms matched up from one continent to another that are nowhere close now, but maybe millions of years ago those continents were touching. So those were the 4 different kinds of evidence that Wegener proposed in his theory of continental drift. What he could not explain is that he couldn't explain how the continents moved. He didn't know why they moved, how they moved, and that was discovered much later. So I'm going to just briefly talk about how they move. We talked about convection a little bit in layers of the earth notes, where you've got hot rock rising in the mantle. It cools off the closer it gets to the crust, and then it sinks back down. So we've got this movement of rock in the mantle, and you can kind of see in this image down here, we've got hot moving, it comes up, cools off, and then it sinks. So it creates a circular pattern. And in this case, it's causing the crust to move apart in this area. We're going to talk about other plate boundaries later, but basically what's happening in the mantle and in the asthenosphere is what caused the plates to move, even though Wegener did not realize that at the time. So some discussion questions, hopefully you can answer after these notes. Who was the scientist that proposed the theory? What is his name? What evidence did he have? And then, based on today's knowledge, how do the continents move? So in his day, Wegener was thought of to be a crazy person. He was not acknowledged. His theory was dismissed by scientists. And now people think he is a brilliant man. So there's our meme for these notes. And don't forget, science rocks.